You know, modern software development absolutely loves object-oriented design. It's powerful, it's flexible, but here's the thing. In the world of safety-critical avionics, flexibility can start to look an awful lot like unpredictability. And that creates this fundamental clash between how we like to build software today and the incredibly strict demands of certification. That's the challenge we're going to unpack.
So it all starts with this simple yet kind of profound problem. In object-oriented software, the code that runs may not be the code you see.
For instance, you could have a base class that gets overwritten by any number of subclasses. A call to a virtual function can dispatch dynamically, which just means the decision about which exact piece of code to run is made on the fly, at runtime, not when you compile the software.
Now, you have to square that with the absolute bedrock of avionics safety. Certification isn't a suggestion. It demands proof of determinism. You have to be able to prove with cold, hard evidence exactly what the software is going to do in every situation you can think of.
And that leads us right to the big, unavoidable question. How on earth do you certify software when its behavior depends on this runtime binding? How do you prove something is deterministic when the execution path isn't even fixed?
Well, that is the exact challenge that the standard DO-332 was created to solve. It's the bridge between the power of object-oriented technology and the non-negotiable safety requirements of airborne systems.
Okay, so let's formally introduce this thing. We're looking at DO-332, which is the Object-Oriented Technology Supplement. Its whole purpose is to clear a path so these modern software practices can actually be used safely in the sky.
Now, what's really interesting here is that word supplement. DO-332 doesn't throw out the foundational standard, DO-178C. Not at all. Instead, it provides very specific guidance. Think of it as additions and clarifications to help you apply the principles of DO-178C to the really unique challenges you get with object-oriented tech.
So why do we even need it? Well, the reason is pretty straightforward. Avionics systems just kept getting more and more complex, and old-school procedural programming was starting to buckle under the weight. Object-oriented technology, or OOT, was a natural fit to help manage all that complexity and reuse code. But, and this is a big but, those powerful features like polymorphism and dynamic binding, while awesome for developers, created brand new headaches for verification. If you don't use them just right, they can lead to unpredictable behavior, which is the one thing you absolutely cannot have on an airplane. So DO-332 is basically the rulebook for doing it safely.
All right, let's break down the core verification challenges that OOT brings to the table. We're going to focus on this idea of non-determinism and what the standard calls hidden behavior.
At the center of everything is this concept called dynamic binding. This is the magic that lets a single line of your code act differently depending on what's happening at runtime. It's how a program can decide in the moment which specific method it needs to call.
And this right here perfectly illustrates the problem for certification. Dynamic binding creates what you can think of as a hidden control flow. An engineer or an auditor can't just look at a line of source code, the call site, and know for sure which version of a method is going to run. The link between the static code you read and the dynamic code that actually executes, well, it's been broken. And when you boil it all down, the key issue here is determinism. If you don't have a predictable control flow, you simply cannot prove that the system will do exactly what you designed it to do every single time. And in this business, that proof is everything. This has a huge direct impact on one of the cornerstones of verification: structural coverage. With OOT, it's not good enough to just show you've tested the source code you wrote. You have to prove you've covered all the possible execution paths that could come from a polymorphic call. And that even includes hidden stuff the compiler generates like virtual tables, or vtables, which are basically the lookup tables the program uses to figure out which function to call. Your verification has to go all the way down to the object code level.
Let's make this really concrete. Imagine you have a virtual method called calculate_thrust. A single call to that method might run the specific code for a jet engine, or it might run a totally different piece of code for a turboprop engine, all depending on the object's type at that exact moment. DO-332 is crystal clear. You have to provide evidence that you have tested both of those execution paths and any other one that's possible. Just showing the line was covered once doesn't cut it anymore.
Okay, so beyond dynamic binding, OOT also makes a couple of other critical verification tasks more complicated: coupling and traceability. We still have to prove how all the software pieces are connected, and that's just a lot harder in an object-oriented world.
Data and control coupling analysis, that's really all about proving you understand how your software components interact, how they share data and how they affect each other's execution.
When you have objects being created and interacting dynamically all over the place, just mapping out those dependencies is way more complex than it is with simple static function calls.
Traceability gets a total makeover too. In traditional procedural code, you trace a requirement down to a specific function or maybe a module. It's a pretty clean mapping. But in OOP, the functionality is spread out. A single requirement might be implemented across a bunch of different methods and attributes inside a class, or even across an entire hierarchy of classes.
And the guidance itself couldn't be clearer about this. This is a direct quote from the standard. All functionality is implemented in methods. Therefore, traceability is from requirements to the methods and attributes that implement the requirements. It's a complete paradigm shift for traceability, and all of your verification evidence has to show it.
Let's just pause on this for a second, because it's so important. Certification does not assume behavior. It requires proof. You can't just say, "Trust me, the design is good." You have to produce the objective evidence that demonstrates it, and that evidence has to cover every method, every attribute, and every possible interaction.
So, what does this all mean for you in the real world? Let's quickly summarize the actual impact on your certification work, what really changes, and just as importantly, what stays exactly the same. Let's take a moment here, because this slide brings it all home. First, let's look at what changes. Your verification focus now has to go beyond the source code to include the object code and all that hidden compiler logic. Your plans have to explicitly talk about how you're handling dynamic binding and class hierarchies. And, maybe most critically, you now have to verify every single possible resolution of a polymorphic call. Now, what doesn't change is just as important. The fundamental rigor of DO-178C, totally intact. The absolute requirement for objective evidence, non-negotiable. And those really high standards for structural coverage, like MC/DC for the most critical DAL-A software, are still the gold standard. You just have to apply them in this more dynamic environment.
So after all of that, if there's one single thing you take away from this, what is it? Well, the crucial point is this.
Object-oriented structure does not remove evidence requirements. All the elegance, the reusability, the raw power of OOT, none of it gives you a waiver from the fundamental need to produce verifiable proof of correctness. DO-332 doesn't make the job easier, it just clarifies how to meet that incredibly high bar in a modern, object-oriented world.